So today we are finding GCF and LCM. So you can kind of see, but GCF stands for the greatest common factor and LCM stands for least common multiple. So if you filled in your notes yesterday like you were supposed to, you should have seen a couple things talking about factors and multiples when we were talking about prime and composite numbers. But if you do not know, factors are numbers that you can multiply together to get a bigger number. So the factors of 6 would be 1, 2, 3, and 6. Whereas multiples, you should think multiply. You're gonna do your multiplication facts. So the multiples of 6 would be 6, 12, 18, 24, and so on. So that's a quick little tidbit for that. But I'm going to teach you today how to find GCF and find your LCM. We're gonna start by listing out the factors, which is a really long and tedious way to do it, but it's very effective, and some of you may like this method more. So if we're just listing out our factors, I like to start like this, do my 6 and a colon, 12 and a colon, and then I start thinking and listing all of the things I could multiply together to get to 6. So I know that 1, I can multiply 1 times 6, but I like to write them in order. I can also multiply 2 to get to 6. I can multiply 3 to get to 6, not 4, not 5, so then I'll skip to 6. And those are all the factors for the number 6. Now we'll do 12. So the factors of 12. You always guarantee 2 factors at least, unless you're dealing with 1. The easiest one to start with is obviously number 1. Think about your divisibility rules that we also talked about yesterday. Can 2 go into 12? Yes, because the last number is even. So 2 is also a factor. What about 3? If you add those 2 digits, like our rule for 3, you get 3, which means that it is divisible by 3. 3 times 4 is what gives you 12. 5 is not a factor, but 6 is a factor, 6 times 2. And I'll skip ahead because I know that 7, 8, 9, 10, 11 are not factors. 12 is a factor. So we've listed out all of our factors, and now all you have to do is match them up. Now, if you notice the key word right here, greatest common factor, if you look there, 6 and 12 have lots of common factors. They actually have 4 different common factors, but we're looking for the greatest common factor. So as you're pairing them up, look and see which one is the largest. In this case, it is 6. So what I will do is circle my 6's. So GCF here is 6, and I'll write that out. GCF equals 6. Awesome. So that is the long and tedious way to find GCF, but I do want to teach you a really quick and easy way to do it. So with GCF, this is called the ladder method. You'll see once we start going, it looks like it ends up being like a little ladder. I do want to make a note that before I start doing these are the 2 examples in your GCF notes. So if you haven't filled out your notes already, please stop. Go get your notes and follow along with me here while I go through these examples. If you've already filled out your notes, that's okay, but definitely grab them and follow along with what I'm doing so you can kind of see how the process works. So what we're going to do is, again, we're using those divisibility rules that we talked about yesterday. We're going to look for the smallest factor or the smallest number that both of these 2 factors have, or both of these 2 numbers have in common. I like to start with the basics. Both of these numbers are even, so I know based on my divisibility rules that 2 can go into both of these numbers. So I'm going to put a 2 right there on the side, and then I'm going to bring my ladder down. So our next step is you're actually going to divide the 2 numbers in your ladder by that factor. So 12 divided by 2 is 6. 20 divided by 2 is 10. So now we've got this second rung in our ladder. You're going to repeat this first step over and over again until you have all prime numbers. So I know, again, both of these are even, so I can do 2 again. I'll bring down my ladder, and then I divide. 6 divided by 2 gives me 3. 10 divided by 2 gives me 5. So based on this, now I know I have all prime numbers. Prime numbers, again, are numbers that only have 2 factors, 1 and itself. So I can stop, and I'm going to grab another color just so you can see the difference in what I'm doing. So once I get here and I have all prime numbers, to find the GCF, all you do is make a G. There's your G. Any numbers inside of your G, you're going to multiply. So I've got 2 and 2. 2 times 2 equals 4. So now I know that my GCF equals 4. How easy is that, right? It's a little bit quicker, and you can see it broken down a lot more. It's very similar to prime factorization, but it keeps it a little bit more organized. So moving on to that second example, if you notice we have 3 numbers instead of just 2. It is important that you notice that, because with GCF and LCM, you're going to do 2 different things when you have 3 numbers. So please pay attention for sure. All right, again, we need to find the smallest factor that all of these have in common. So just to get started, so let's use our divisibility rules. Each of these numbers is even, so the best place to start is with a 2. I'm going to scroll up a little bit so you can see me. All right, 12 divided by 2 is 6. 18 divided by 2 is 9. And 60 divided by 2 is 30. So we've got this. Now we have to figure out our next factor. If you notice, not all of them are even. So I can't just skip to 2 like I did up here. I have to think of the next biggest factor, or the next smallest factor, actually. So I'm going to go down the line of our divisibility rules. What about 3? So if you think back to that divisibility rule, you have to see if the sum of all the digits is divisible by 3, or is a multiple of 3. And in this case, all of them are. So we're going to use 3. Bring down your ladder. Oop, that one's a little small. That's okay though. 6 divided by 3 gives me 2. 9 divided by 3 gives me 3. And 30 divided by 3 gives me 10. So this is where I really need you to pay attention, because this is where the difference happens. If you notice, we have a 2, a 3, and a 10. All 3 of these do not have a common factor, but 2 of them do. I could keep going because 2 goes into both 2 and 10. But with GCF, and there is a place on your notes that should say this somewhere. If not, make sure on the key that you copy down any extra handwriting that might be on there, because I know I made a note of it, at least on my copy. When you're dealing with GCF, if you cannot find a common factor for all 3 numbers, you stop. You don't go any further. So right now I'll stop and let me catch my marker. I'm going to stop and make my G. I'm going to multiply everything in the G. 2 times 3 equals 6. So my GCF equals 6. There you go. So that is GCF. I'll leave it there for just a second so you can pause and copy down anything if I went too fast. All right, so I'm going to scroll back down just a little bit. So you can see LCM. LCM is very, very similar to GCF. It's the same process, except for instead of listing out factors, we're actually going to list out multiples. But you're going to start the same way. 9 and 6 with our little colons. Again, like I said, just start thinking about your multiplication facts. That's how you can list out your multiples. So 9, 18, 27, 36, and 45. It's a good rule of thumb to at least count out 5 multiples. If you get stuck, check your agenda. There is a 100s chart in there. Now let's do sixes. 6, 12, 18, 24, and 30. With multiples, it is a little bit easier to figure out that one. You are looking for the least common multiple, so the smallest multiple that they have in common. Just looking at it straight down, right now they actually only have one multiple in common, which means it is going to be the smallest. So you're going to circle it. It is 18. And then you can write LCM equals 18. There you go. For LCM, you also use the ladder method. It is the exact same process as what we did over here for GCF. So we'll just jump right into it since we already kind of covered how to do it. Think about your divisibility rules. First thing that jumps out to me is that they are both even, so it's a good thing to start with a 2 if you don't know where any other thing or you don't have any other clue on how to start. 2 is always a good place if you notice that both are even. So then we'll divide. 18 divided by 2 is 9. 24 divided by 2 is 12. Now, let's think about them again. Are both of them even? No. So since both of them are not even, let's move down to our next divisibility rule, which is 3. Are both of these divisible by 3? Yes. So let's use 3. Bring down another rung on our ladder. 9 divided by 3 is 3. 12 divided by 3 is 4. Can we go any further? Or all of these are prime. So if they're all prime, you can't. If you've got a composite number, or if they're both composite, then you can keep going. But because we've got prime numbers all the way around, we stop. And this is not GCF, so we're actually not going to make a G, but it's LCM, so we make an L. So make your L, and your same process. You're going to multiply everything in the L that you just made. So 2 times 3 times 2 times 4. 2 times 3 gives me 6. 6 times 2 gives me 12. 12 times 4 gives me 48. So our LCM equals 48. And that is the answer. So once you figure out how to do the ladder, it works for both GCF and LCM, which makes it pretty easy to catch on. The biggest thing that you have to be able to tell the difference between is if you're solving for LCM or GCF, because with the GCF, you're making your G, which stays on just that left side of the ladder. But if you are dealing with LCM, you're dealing with this big old L, so you have to multiply everything on the side and everything on the bottom. But let's go down to this last example. Again, these are also in your notes. Sorry I didn't say it earlier. These are also in your notes under the LCM, so if you did want to copy them down into your notes packet, definitely do that. Similar to example 3 over here, our LCM with 3, it is going to be a little bit different when we get down to this last step. So let's just jump right in. First factor, are they all even? No. What about 3? Doesn't look like it. Doesn't look like 4, but if you know your multiplication facts, you should be able to pick these out pretty quickly. 7 is actually a common factor for all 3 of these. So I'm going to go ahead and put 7. Now let's divide. 14 divided by 7 is 2. 21 divided by 7 is 3. And 28 divided by 7 is 4. Now, here's the difference. We've gotten really small. We're close to having all prime numbers. But if you look, we could keep going because 2 and 4 still have something in common, even though our 3 doesn't. With GCF, you would stop here. But because we're dealing with LCM now, you actually can keep going. So the common factor here would be a 2. So I'm going to put a 2, and I'm going to bring down my ladder. 2 divided by 2 is 1. It does not go into 3, so you just bring your 3 straight down. You don't do anything to it. It doesn't factor out. Just bring it on down. And then 4 divided by 2 is 4. At this point, there's nothing else we could do. So we stop, and we make our L. Once you have your L, you multiply everything in the L. 7 times 2 times 1 times 3 times 2. 7 times 2 is 14. 14 times 1 is 14. 14 times 3 would give me, let's work it out, 14 times 3 is 42, and then 42 times 2 would give me 84. So that means that our LCM equals 84. That is the listing out method and also the ladder method. If you have any questions, please rewatch the video or feel free to email me or message me on Canvas, and we can get you some help that way also. See ya.